Hi everyone, this is Miss Tom with Chapter 9, Closure Day 1. We're going to be talking about this inequality here, but I want to make sure you guys have tried to solve it on your own before looking at the video. So make sure you pause the video, try the problems on your own, and then look back here to see what the solutions are. Alright everybody, so hopefully pause the video and unpaused it. Let's talk about what we notice here. With this one, we're noticing it's an inequality. That is a dashed line. So I'm going to write dashed. The next thing is, because you know it's dashed, we know that it's either going to be greater than or less than. And the reason why it's not equal to is because equal to would be a solid line. But this isn't a solid line. This is a dashed line. So that's what we should have. Also, I want you to notice that it's shaded above the line. Since it's shaded above the line, that means that it is greater than, because something that's greater than is above that line. And then lastly, we're going to look at the y-intercept and the slope here. So that way we can get the inequality that we have here. So first thing is we're going to notice this. That is going to be -2. Alright, so our y-intercept is going to be -2. We're going to write y is greater than. Then we're going to look at our slope. What's our slope? Our slope is going to be rise over run. So it's going to be negative, or 2 up here, 2 up, 4 over. So once again, it's going to be 2 up, 4 over. Got our x. And then we're also going to write -2, okay, because that is the y-intercept. And there's our inequality. Some of you might want to rewrite it so that you have a fraction that's simplified. That's fine as well. So those two answers are what we have as the inequality for this graph. Okay, next one we're going to do is we're going to talk about solutions to inequalities. So all of these up here are considered solutions. So when we look here, we're looking, is 0, 4 considered a solution to both of these? How do you check it? Well, you check it by actually putting it into the equation, or the inequalities. So when we have this, we've got, I'm rewriting the first one. Looks like that. And then the other one, again, I'm rewriting it over here. This. Okay, so let's keep going. 0, 4 is what we have. This is x, this is y. Y would be 4. Then we're going to write 3, and then instead of x, we're going to write 0 plus 4. Then we notice 4 is less than 4, which is, or less than or equal to 4, which is a true statement. Since it's true, we know 0, 4 works for that inequality. But if we look here, and we look for this inequality, let's go ahead and write what we know. We said that y was 4, and that x was 0. So we look here, 4 is greater than -2. Is that a true statement? Yes, it is. And so, since it's a true statement for both of them, we can say that this is a solution to both equalities. So 0, 4 is a solution. Yay! Okay, let's keep going. Next one, it says, Lou has a granddaughter named Audrey. And it says, even if you tripled your age and added 9, you still wouldn't be as old as I am. And Lou is 60 years old. So it says, triple your age and added 9. Well, let's talk about what triple mean. Triple means 3 times your age. And then we're going to go say, added 9. Added 9 is going to be plus 9. The next thing it says, you still wouldn't be as old as I am and Lou is 60 years old. Since it says you wouldn't be as old, that means less than 60. So now let's try to figure out what is the possible age that Audrey could be. So we're going to go ahead and solve this inequality. Remember, inequalities are solved very similarly to equations. All it is that instead of an equation, we've got an inequality. So we've got 3x is less than 51. Then we're going to divide by the coefficient, which is 3. I hope that you're solving it with me. That way you guys can ensure that you have the right answer. Okay, then we go 1 and 7. So that means that Audrey is probably less than 17. All right, so that's her age according to information given. How'd you guys do? Hopefully you got it right. Next, let's go over this one. It's talking about bowling. You guys like bowling? Yeah? Okay, well it says the bowling rental fees decreased 10% per year over the past several years, and if the current cost is $5, write an equation to model this information. Also, it's talking about exponential, so remember that we want to use our exponential formula, which is y is equal to a times b to the x power. Okay, so that's what we're going to do. Alright, but first it says decreased by 10% per year. 10% per year. So if we're at 100 and it decreased 10% per year, that means it's this way, and that means we're here at 90%. So we know it's 10% each year it decreased, so we're 90% each year. Also, in this question, we know that the current cost is $5, so we would say y is equal to $5 was the initial starting amount at time 0, but everything that keeps happening is this value keeps getting multiplied by 90% of the previous year, so then we're going to say there's our equation. So let's take a look at what we know. Since it's decreasing, is it appreciation or depreciation? In this case, since it's decreasing, we're going to call it a depreciation. Also, right here, x is going to be the years, and y is going to be the money. Okay, so now let's go ahead and write what we know. 0, 1, 2, 3, 4. Okay, so at year 0 it's going to be 5, but every time we get multiplied by the previous number by 90% of the original. So let's go ahead and do that. So we're going to go 5 times 90%, we get 4.5. Okay? And then once again, you're doing another 90%, timesing by another 0.9, which is 0.09, 4.05. And then continuing on, that's going to be again multiplied by a 0.9, which is 3.645. 3.645, and then again we're going to go ahead and multiply that again by another 0.9, which got 3.2805. 3.2805, and that's because every time it's decreasing by 10% each year, so that means it's only worth 90% of what the original is. Okay, so now let's graph it, shall we? 0, 5 is going to be here. 1, 4.5 will be... Actually, why did I say that was 0, 5? That's like 0, 3. Anyway, I was wondering. Mistakes are expected, but yeah, okay, anyway. 0, 5's there. 1 is 4.5's here. 2 is 4.05. It's kind of like there. Then 3 is 3 and 6, 4, 5 kind of there. And then 4 is about here. So what's happening here is we've got a little bit of a curve. It's going to curve down like that. and curve up like this. Actually, I'm going to do that again. Something like this. All right, and voila, we've got what is the projected prices of the bowling shoes. Okay, let's keep going. Next, what we're going to do is we're going to solve a couple of systems, and then we were almost done. Hang in with me. You guys got this. We can do this. Okay, a couple of things with this one. It says 2x minus y is equal to 9, and then y is equal to x minus 7. With this, we want to make sure we substitute in this value here right into here. That's one method, or you can also do the equal values method. And with this one, I think I'm going to just show you one method, and then you'll just kind of use that method. I actually think instead of the equal values method, let's use the elimination method. So what I'm going to do is I'm just going to rewrite the first one so that it looks like this, and then this one I'm gonna subtract that x to this side. What I do to one, I do to the other. Then this goes by. So then we have the other equation, which looks like this. Then we're going to go ahead and solve. Okay? And the great thing, the reason why I did this is because now you can go ahead and circle as your zero pair. Okay? So I'm going to draw our line here, and we're going to notice we can circle our zero pair. This is a zero pair, goes out. So now we're at x, and then we go 9 minus 7, which is 2. So we know that x is equal to 2. Then the next thing is we notice we've got this equation, y is equal to x minus 7, where instead of x, we're going to write 2, because that's what we had earlier. Then we're going to subtract the 7, so we get y is equal to negative 5. And there it is. We have the system solution, which is 2, comma, negative 5. And there we go. All right, everybody, let's go and move on. Okay, now we have this one. Again, I think I'm going to just teach you guys how to just do the elimination method, where you just use that method for everything. You could use substitution method, but I think just to keep things consistent, I'll just use the elimination method for solving the system, where you're trying to solve for x and y. Remember, when you're doing these problems, I know sometimes it's like this is a lot of procedure, but really what's happening is that you've got a line, you've got another line, and the solution is basically where do they intersect. And sometimes you're going to see that in real life where you're like, when do they go together? When are they the same? So then we're going to go ahead and look here. We're going to add y to both sides here. And so this goes by. So then we have 2x plus y is equal to negative 13. Then what you're going to notice is that the y's are going to end up having to cancel out. So this, you're going to multiply by negative 1. That way we have something to eliminate. So let's do that. We've got negative 4x plus y is equal to 5. The negative 1 gets distributed. So it's negative 2x minus y is equal to positive 13. Then we notice that this goes away. We end up getting negative 6x is equal to 18. And then finally, we're dividing by negative 6, which we get x is equal to negative 3. And when x is equal to negative 3, how do we solve for y? Well, we need to put it back into one of these equations right here. So let's go ahead and put it into this first one. negative 4x plus y is equal to 5, where we put in negative 4, but instead of x, we're going to put in negative 3 plus y is equal to 5. Then we've got a negative times a negative, which is 12 positive. Then we say plus y is equal to 5. Then we're going to go ahead and subtract the 12. What we do to one, we do to the other. This goes by. So we get y is equal to negative 7. There's our answer, and we've got our solution. So our solution is negative 3, comma, negative 7. How'd we do on that one, you guys? Better? Hopefully, pretty good. All right, and then finally here is our last question. We've got inequalities. Let's do this. So when you're doing absolute values, let's do this. So in doing this, I want to make sure before you even remember what to do, remember absolute values actually have two answers, because this could have an answer of, actually I'm going to rewrite that, sorry guys. This could have an answer of 5, or it could have an answer of negative 5. So when you're finding the absolute value of something, it could have two answers. So I want you to try these problems out. I'm going to pause the video. Okay, so they should have two answers, meaning x could either equal 5 or it equal negative 5. One of those answers. All right, so we're going to go ahead and subtract 3 here. Both sides. This goes by. And now we have the answer, absolute value of x is equal to 5. So now that you know you're trying to find the absolute value of 5, then that means you know that x can either equal 5 or it could equal negative 5. Because when you're looking at the number line and you want to know how far is something, if it's 5 away, it could have two answers. This one or this one. Okay, let's go over B. B is a similar kind of thing here. We know that it could either be positive or negative, so we're going to have two routes, one of them being positive, one of them being negative. So we're going to go with the first one, equals to positive 17, and the other one, we're going to go with negative 17. So let's take a look. With this one, we know it could be positive 17, so if I add 5 to both, I'm going to know x is equal to 22. That's one possible solution. And then the other one, we got plus the 5. That's another possible solution. All right, everybody, thanks so much for watching. We're going to do closure day 2 in the next video. But remember, it's always important that you try to solve the problems on your own first before looking at my solutions. All right, thanks everybody, and I'll see you guys for the next video.